guys. Today we'll be learning about NCR, basically defined as entries are beginner problems. You may have an idea, like you have no idea of NCR, that's okay. We're gonna learn about this. So, how many rectangles can be formed by following the lines in the 8x5 rectangle below? So here's the 8x5 rectangle with these lines and rectangles inside. So we want to know how many there are. So before we start plowing through the entire thing, trying to find a solution, actually, listen, I'm trying to show you something. So here, it's not just 1x1 rectangles. We're talking about 2x2s, 3x2s, 4x2s, 5x2s, all these 9x6s. No, there's no 9x6s. 8x4s, all these kind of rectangles, every single rectangle. And they can be formed by the lines, by following the lines. Here, just to make that clear. Solution. Before we start plowing through the entire problem, looking for every rectangle, which would of course take like 20 minutes, we must look for a logical pattern. So before we go to the logical part, which is a step ahead, how do you define a rectangle? When you're trying to do all these kind of mathematical things, it's best to define something before you go to the logical pattern. Most people will say that it has 4 sides, 90-degree angles, and other things, but we must look for the relevant information. Since we're picking a rectangle out of a huge rectangle, the answer is it has 2 points on the width and 2 points on the length. So we can easily see this is the huge rectangle, we must choose a rectangle, which means we must choose 2 points from the large rectangle on the width and on the length. To show you what I really mean, let me show you now. So if I have a rectangle right here, I'll try it. So here, this is the length, and this is the width. So we have 2 points right here, because 1, 2, here 2 points. So we want to choose 2 points out of the huge rectangle. So let's just go back here. So we choose 2 points, let's say this and this, and over here. Let's do some random things right here. And so now what you have to do is treat this like a graph. So treating this, after you treat this like a graph, you'll get different rectangles. That's what we're looking for. We're not actually looking for a unique, because if there is unique, like if I just write down the word unique, and then space, we're not looking for unique. Okay, so let me erase that. Okay, just gonna leave a few here. And let's go. So we need to use 2 points from the larger rectangle on the width and on the length. But how do we get it? So okay, we have tackled a large part of the problem right here. We found out the logical part was choosing 2 points out of the large rectangle on the length and the width. But our problem is here. How do we choose 2 points from multiple points? So here's our main question, and this is where the NCR kicks in. So trying to highlight the entire thing. It's about most of it. But yeah, just keep it like this. Whoops. Okay. How do we choose 2 points from the multiple points? So we can see that the title page is NCR, which means entries are. We're choosing R elements from N elements. And then there's a formula for this. N, R, this is how it's defined. So we go like N, and then R on the bottom, and then a parentheses all around it, called N choose R, is equal to N factorial over N minus R factorial, R factorial. So we want to choose for the length 9 points and choose 2 points. For the length, we have 9 points, and we want to choose 2 points out of the 9 points. So the 9 points is a huge element. So what we had to do is NC2, and then for the width, 62, because there's 6 points. But isn't there supposed to be 8? And here 5, because it's an 8 by 5 rectangle. So if you go back, we're supposed to look for the points. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Because through the points we can form the rectangle. Here 1, 2, 3, 4, 5, 6. Oops, let me erase all the ink. And so this is actually not the 8 and 5, it's 9 and 6, so be careful with that. So NC2 and 6C2, which is 9 factorial. 9 factorial divided by 7 factorial times 2 factorial, and 6 factorial over 4 factorial times 2 factorial. Because, of course, here, if you do N, and, well, let me erase everything. Okay, so here we have 9 and 2 here. This is equal to 9 factorial. 9 minus 2 is equal to 7. 7 factorial, 2 factorial. Imagine that these two always add up to the bigger number. The bigger number always is up at the top. The other way I really do this is I put the R over here and then do the N minus R over here. So we can do an 9 minus 2 equals 7. Otherwise, you can do 7 plus 2 is equal to 9. So it should be x plus y is equal to z. If you think this is x, this is y. Get more of the algebra type. So we can do the n factorial, 9 factorial divided by 7 factorial times 2 factorial, and this right here. This is equal to 72 divided by 2. We've got 36 from the length here. It's 36. Here's a 36, and then 36, and then 15 ways to choose from this one. Here we want to multiply them together, which results in 540 rectangles. So we're using the product of this because we have 36 ways there, and then 15 over here. Oh, let me make this bigger. Like that. We want to multiply these together to get the number of rectangles in here. Thanks for watching, and please look out for more videos from us.